online teaching platform. Still on finding the derivative of a rational function from the first principle. So we have to find the derivative of the function 1 is divided by x plus 1 from the first principle. So let us state the function first. We have the function to be y is equal to 1 divided by x plus 1. So this implies that our original function is 1 divided by x plus 1, which is f of x. Alright, so let us find our f of x plus h. So it means if you have f of x to be 1 divided by x plus 1, it means your f of x plus h, you are going to replace x with x plus h. Alright, so this will give us 1 divided by, so wherever you see x, you put x plus h over there. So it's going to be, here will be x plus h. So let me bring it back. So x plus h. So now we are going to get it plus, so 1. Alright. So we have replaced the x with x plus h. And this will give us, so we need to simplify. So we'll be getting our numerator to be 1 and our denominator will be x plus h. I think we can, so we'll leave it in this form. Right. So let us now state our formula for finding the derivative of a given function from the first principle. So the formula is dy dx is equal to the limit of f of x plus h minus f of x, the original function, all divided by h as h approaches 0. Alright, so we need to find the difference in the f of x plus h and the f of x. So let us bring down the numerator. Our numerator is f of x plus h minus f of x. Now we know our f of x plus h to be 1 divided by x plus h plus 1, then minus the original function, which is 1 divided by x plus 1. Alright, so we need to find their LCM, which will be the product of the two denominators. So we are going to get here to be x plus h plus 1 in one bracket, also multiplying x plus 1 in the other bracket. Right, so we divide the first bracket, we divide the denominator of the new fraction that we are getting by the denominator of the first part of the fraction. So that's the first fraction. So you'll be getting, when you divide this denominator, when you divide the denominator here, let me use this. So this is the denominator that I'm talking about, this particular one. So when you divide this denominator by the denominator of the first fraction, you'll be getting a result of x plus 1, and that's why we multiply the 1, which is the numerator of the first fraction. So in bracket x plus 1. Now you now use the denominator of the second part, that's the second fraction, to divide the same LCM, and you'll be getting x plus 8 plus 1. So everything multiplied by -1. So x plus 8 plus 1 in one bracket. So we continue to work on it, and this will give us x plus 1. The -1 times will be a negative x. -1 times h will give us negative h. And the -1 times -1 will give us, -1 times +1 will give us -1. All divided by x plus h plus 1 in one bracket, multiplying x plus h in the other bracket. Do not waste time on the denominator. trying to expand it. So we just leave it. Let us work on the numerator. So we are getting, so this, we cancel this. So x minus x. And we have another one, 1 minus 1. So we are left with negative h as the numerator. So the numerator becomes negative h. Alright, so the denominator is still the same as x plus h plus 1 in one bracket multiplying x plus h in the other bracket. Alright, so this becomes the result for f of x plus h minus f of x. So let us substitute it into the formula. So we have dy dx being equal to the limit of, so we have our f of x plus h minus our f of f to be this result. So negative h all divided by x plus h plus 1 in one bracket multiplying x plus h in the other bracket. So we need to divide everything by h as we have in the formula. So we can write it as in this form, divided by h. And we should know that h is the same as h divided by 1. Alright. As the h approaches 0. So we can now continue. We are going to get the limit of negative h all divided by x plus h plus 1 in one bracket multiplying x plus h in another bracket times the reciprocal of h. So that becomes 1 over h. And you can say this and this cancel each other. So we are left with negative 1 over here. So negative 1 over here. So that just brings us our h approaches 0. So we now have negative 1 divided by, that's the limit of negative 1 divided by x plus h plus 1 in one bracket multiplying x plus h in the other bracket. Oh, I'm coming. Let me check if I think there's a. All right. The denominator here is 1. Yes, let me correct it. It's x plus 1, not h. So that's the original function. Let me correct this side also. All right. So let's continue now. So as our h approaches 0, so we can now plug in the value of h to be 0. So we have negative 1 all divided by, wherever you see h, you put 0 over there. So here will be x plus 0 plus 1 in one bracket, also multiplying x plus 1 in the other bracket. Alright, so we continue to simplify and we'll be getting negative 1 divided by, the first bracket becomes x plus 1 multiplying x plus 1. And this will give us the final result as negative 1 divided by x plus 1 or in brackets square, because x, the number times itself is the same as the number to the power 2. Alright, so we conclude that our dy dx, that's the derivative of the function y with respect to x, is equal to negative 1 divided by x plus 1 or square. Thank you for watching, and please do not forget to subscribe to my YouTube channel, which is Math with Ebefa. Thank you. Bye.